Hey guys, Ms. Michelson here. Today I'm filming a video going over the topic 1 remediation for Algebra 1. And we're starting off with section 1.1, which is operations on real numbers. The first thing that we are asked to do is order from least to greatest. So we've got three numbers here. We just want to order them from the smallest to largest. But the weird thing that we've got going on here is that we've got some radicals and we've got some decimals and some fractions, and we don't really generally have a good idea of what these numbers are. So the first thing I'm going to do is turn every one of these into a decimal, which requires me to have a little calculator on hand. If you need the Desmos calculator or like a handheld calculator, you might have access to one. So I'm going to type in this first number that I see, making sure that the whole fraction is underneath of the radical. Ooh, that wasn't the button I wanted to press. And my calculator will help me simplify this. So radical 12 divided by 3 really is the number 2. This 1.01 is already a decimal, so I'm not going to simplify that one. And so then lastly, I want to get rid of the radical. I want to turn it into a decimal. And I can do that by typing that into my calculator. This is really 0.3. So when we want to order these from smallest to largest, now that we've simplified all of our numbers and we've got decimals where we need them, now it's a little bit easier for us to understand what the value of each of these terms are, and then we can order them from smallest to largest. So the smallest one that I see is this 0.3. I'm going to write my answer in the original form of the problem. So 0.3 was the smallest, but I'm going to take it as radical 0.09. This 1.01 is in the middle. And then last but not least, the largest number was 2, but I'm going to write it in the way that the problem was expressed to us. So the radical 12 divided by 3 goes next. And then the next problem in this one is asking us to list the subsets of the real numbers this negative 10 belongs to. And for this problem, I'm going to use a diagram that I'm going to put up on the screen to help us kind of talk through this problem. But we got to remember, we want to list the subset of real numbers that it belongs to. So the first thing that I'm going to show you, I like this visual here on this screen, talking about different groups of numbers. And this one's kind of acting like it's like a funnel or like a cup. So there's a bunch of different ways we can classify a number. And if we classify something as a natural number, it is also a whole number, and it flows into integers, it flows into rational, and it flows into real. But say something we classify it as just an integers, that's the highest we can go, then it also belongs to the rational numbers, and it also belongs to the real numbers. So we need to figure out for our number negative 10, what is the highest cup that it will go into, and then we get to list all of the other categories that go below it. So that just requires us to have an understanding of what these different groups of numbers are. So rational numbers are things that can be written as a fraction or a decimal that is either repeating or it terminates. So it doesn't go on forever. And then our integers is like every number in the world. Negatives are included in there, and then positive numbers as well, and 0. The whole numbers are 0, and then every positive counting number. And then the natural numbers are only positives. So like only the positive ones that fall in there. So if we wanted to classify our number negative 10, well, it is definitely an integer. It's not a whole number though, because it's not 0 or positive, and it's not a natural number. So the place where it would fall into is integers. And then I'm going to go back over here to figure out the other groups that it falls into. So it's an integer, which also means it's a rational number, which also means it is a real number. So I'm going to classify it as those three terms. It's most specifically an integer, but it's also a rational, and it's also real. So that's just a little bit of number classification there. Now we get into the fun part of section or topic 1, section 1.2, which is solving a linear equation. So we've got some steps that we need to follow when we're solving a linear equation. We are wanting to follow PEMDAS, right? And the first thing we need to do is start with our parentheses. Well, I have x minus 3 out in front of, or in these parentheses here, and I have a negative 5 out in front of it. So what we're going to do is we're going to distribute that negative 5 to get rid of those parentheses. Negative 5 times x is negative 5x. Negative 5 times negative 3 is a positive 15. So I've got negative 25. And now, I don't have any exponents. I've got some multiplication and division and adding and subtracting in there as well. So we really are hoping to isolate x. We want to get x all by itself. So I need to undo everything on the same side as this x. The first thing that we have to get rid of is any constant terms. So this plus 15 is in the way. I need to move it to the other side of my equal sign by subtracting 15. When I do that, my positive 15 minus 15 cancels out. I'm left with negative 5x. And then I have to do this subtraction over here. Negative 25 minus 15 is negative 40. And our goal still is to get x by itself. So the last thing that is attached to x right now is a negative 5. I'm going to divide both sides by negative 5. The opposite of this multiplication is division. Those negative 5s cancel out, so I'm just left with x. And then I need to do negative 40 divided by negative 5. That's something that I can type into a calculator if I need to. Negative divided by negative is a positive, and then 40 divided by 5 is 8. So my final answer there is x equals 8. The next one is same type of problem. We're still going to solve a linear equation. However, we need to come up with that equation on our own. So this one tells me the sum of 3 consecutive integers is 78. So I'm taking 3 things, 1, 2, 3. The sum of them means I'm adding them together, and the total is 78. So I need to figure out what these 3 numbers are. And our other keyword here is consecutive. When we have consecutive numbers, that's like 2, 3, 4, 11, 12, 13. They're right next to each other on the number line. So if I don't know what the first number is, I'm going to call it x. But I know that the next consecutive number is x plus 1. And the number after that is going to be x plus 2. Because they're consecutive, they're in a row. So I've built my equation to find what my 3 integers are. I really am just solving for x. So when I solve for x, I need to combine any like terms that I have. So I have 1, 2, 3 x's that I'm all adding together. So x plus x plus x is 3x. And my other like terms that I have are positive 1 and positive 2. 1 plus 2 is 3. So I have 3x plus 3 equals 78. Again, now we're kind of looking like our problem that we just did. I have an x over here. I want to get it by itself. The first thing I have to get rid of is this plus 3. What is the opposite of adding 3? Well, it would be subtracting 3. I'm going to get 3x. These 3's cancel each other out. 78 minus 3 is 75. And I'm still trying to get x all by itself. It has a 3 out in front of it right now. They're being multiplied together. What's the opposite of multiplying by 3? Well, dividing by 3. And when I do that, my 3's cancel each other out. I'm left with x equals 75 divided by 3 is 25. Now, what does x represent? X represented that first number in my list. What's my next consecutive number? Well, it's x plus 1, or like the next one in the row is 26. And then last but not least is 27. We can check our answers here. Remember, we said if we added all of them together, it should equal 78. And that's what I get. So that one was just a little bit of a word problem there. Section 1.3, same deal here, except for now we're going to have variables on both sides of our equal sign, which just makes our problem a little bit more challenging. The first thing we need to do whenever we see a set of parentheses in our problem is distribute. And lucky for us, we got to distribute on both sides of our equation. This negative sign, when I distribute it, is just going to turn or switch the signs of my two terms already. So that 5a is going to turn negative, and this positive 6 is going to turn negative. And I'll distribute on the right-hand side as well. 2 times 3 is 6a. 2 times 8 is 16. And that's going to stay a positive 16. Sometimes it's helpful if you want to draw a line through your equal sign right here. So you know that what you do to one side, you always have to do to the other side of the line. And before we can start adding and subtracting or dividing, the problem that we're facing right now is that we have two A's. We have an A on the left-hand side and an A on the right-hand side. So we need to combine those together. So I'm going to take my negative A's and I'm going to move them over to the other side of my red line or the other side of my equal sign. So I have to ask myself, what's the opposite of subtracting 5a? Well, it's going to be adding 5a. And I'm going to line my A's up so it makes it a little bit easier for me in the long run. Negative 5a plus 5a is going to cancel out. I'm just left with negative 6. 6a plus 5a is 11a. And then 16 is just going to drop down along for the ride. I couldn't do anything with that 16. So now I am going to do what we did in our last problems. Now I just have one place where I see an A. So now I can follow my steps that I normally do. I need to get rid of any addition or subtraction. What's the opposite of adding 16? Well, it would be to subtract 16. When I do that, my 16s cancel out. I'm left with 11a. Negative 6 minus 16, if we get negative numbers can be tricky, so we always can put them in our calculators if we need. When I do that subtraction there, I get negative 22. And again, our whole goal is to get a by itself. Right now it has an 11 out in front of it that's being multiplied. The opposite of multiplication is division. My 11s are going to cancel out. I'm left with a. Negative 22 divided by 11 is negative 2. So a equals negative 2. Now our next problem, again, is a word problem, but we're going to just take it step by step. It says a square and rectangle have the same perimeter. So when we're talking about a perimeter of a shape, we're talking about adding all four, I guess the squares and rectangles have 4 sides. We're adding all 4 sides of those shapes together. But they have the same perimeter, so that's going to come in handy for us. It says the length of the side of a square is 4x minus 1, and the length of a rectangle is 2x plus 2, and the width is 2x. We want to write and solve an equation to find x. So I know that the perimeter of the square equals the perimeter of the rectangle. I'm going to abbreviate there. So I just need to write an expression for the square. I need to write an expression for the rectangle, and the equal sign goes right in between the two. The perimeter of the square Well, the side of the square is 4x minus 1. And on a square, we know that all four sides are the same. So if this side was 4x minus 1, this one's 4x minus 1, this one's 4x minus 1, this one's 4x minus 1. So when I'm adding all four of those sides together, that's really the same thing as 4 times 4x minus 1, because we see this expression show up 4 times. Now, for my rectangle, it's not as simple as that, because we know rectangles have a length and a width. So we have two sides of the shape would be 2x plus 2. And then the other two sides, they tell us, are just 2x. So I'm going to label this rectangle here, 2x and 2x. So when I'm finding the perimeter of the rectangle, I have two 2x's plus 2's. So I'm going to write 2 times 2x plus 2. And then I'm adding to that my two 2x's. So 2 times 2x. And now we've got a problem that looks really similar to our last one. And we need to first distribute throughout our parentheses. 4 times 4 is 16. 4 times x is x. 4 times negative 1 is negative 4. Let's distribute here in pink. 2 times 2 is 4. X. 2 times 2 is 4. And distributing here, 2 times 2x is 4x. Now, what we want to do is identify any place that has an x. We have an x here, we have an x here, we have an x here. That's our main goal, is to get x all by itself. I'm going to draw my line. But when I have two x's on the same side of my equal sign, I have to deal with those first. So I'm going to add 4x plus 4x over here, and that's going to give me 8x plus 4. And that 16x minus 4 is just going to stay on the left-hand side. And now that I've consolidated one side of my expression, I've got two x's floating around in my problem. This is when I need to take the smaller one and move it to the other side. This 8x right now is positive. The opposite of a positive 8x is a minus 8x. When I do that, I'm left with 4 on the right side. 16x minus 8x is 8x. And then the negative 4 just gets to drop down. Now I've just got one x in my problem. So I'm ready to rock and roll. I gotta slide my paper up. I'm going to add 4 to both sides of my green line. My 4's are going to cancel out. 8x equals 4 plus 4 is 8. And last but not least, I want to get x by itself. Right now it's being multiplied by 8. The opposite of multiplying by 8 is dividing by 8. 8 divided by 8 is 1. So x equals 1 in my problem. Again, a word problem, but if we take it step by step, we get an equation that we know how to solve. We're going to flip over to the next side. Section 1-4 is literal equations and formulas. So the first one is just asking us to rewrite an equation to solve for m. So a literal equation is just going to have a couple variables floating around in them. The idea is that we want to get 3m by itself. And we're doing that the same way we would when we were solving for x in our last problems. But this time, instead of just moving numbers over, we're going to group together this 3 and n. It's on the same side of my equal sign right now, so I need to move it over to the other side. The opposite of adding 3n is going to be to subtract 3n. When I do that subtraction, I'm just left with m on one side, but I'm kind of stuck here. This 7 and the negative 3n are not like terms. I'm not allowed to add or subtract them, so I'm just going to write them next to each other. I'm going to have 7 minus 3n. And this is a little bit weird, but we've got m by itself now. So that's going to be our final answer. We don't have to do anything else as long as we've got m by itself. So I'll write my final answer on this line. 7 minus 3n is going to be it. Our next one, again, is probably like the same type of problem here, but we have to write our equation ourselves. So again, we're talking about a rectangle, and it has a perimeter of 182 and a length of 52, and we want to find the width. So we know that the perimeter of a rectangle is going to be 2 times the length plus 2 times the width equals our perimeter. So maybe I should have written that down here. 2 times the length plus 2 times the width equals the perimeter. And we're going to plug in what we know. Well, we're given the perimeter was 182. And we're given that the length was 52. So 2 times 52 plus 2w equals 182. And we want to solve for the width, which means we want to get w by itself. The first thing that we want to do is simplify anything in our problem that we can. So 2 times 52, when I type that into my calculator, I get 104. Let me double check that. Yep, I get 104 plus 2w equals 182. I'm going to subtract 104 from both sides because I'm trying to get w all by itself. When I do that subtraction, I'm left with 2w equals 182 minus 104 is 78. And last but not least, I'm going to write this over here. 2w equals 78. To get the w by itself, I'm going to divide both sides by 2. W equals 39. So we can say the width of a rectangle is 39. Now we're moving on from equations to inequalities, and we're going to solve them in a very similar fashion. So I'm going to treat this inequality, this less than sign symbol, just kind of like it's an equal sign for now, and then we'll talk about how we write our final answers. So whenever I see a problem that has a set of parentheses, I want to go ahead and distribute. Negative 3 times m is negative 3m. Negative 3 times negative 4 is plus 12, which is less than 6. I keep this less than sign kind of all the way through my problem. Our goal right now is our goal that we've had this whole time is to get m by itself. So right now, the m we have this plus 12 right over here. So to move it to the other side of my inequality, I'm going to subtract 12. Negative 3m is going to be less than 6 minus 12 is negative 6. And last but not least, to get m by itself, I want to divide both sides by negative 3. When I do that, I get m all by itself. Then negative 6 divided by negative 3 is 2, and negative divided by negative is a positive. But there's one thing that we have to remember. Whenever we divide by a negative number, so I've divided by a negative 3, we have to flip the inequality sign. M is going to be greater than 2. So that means m could be 3, could be 4, it could be 5, it could be 10 million. So we want to write that on a number line. So what I'm going to do is I'm going to take my number that I have, 2, and then I'm going to put a number to the right of it and a number to the left of it. When it's a greater than sign or a less than sign, it is an open circle, and we shade in the direction which it's pointing. So kind of shading over here to the right. I'm going to put an arrow here. M can be any number that is greater than 2. So in that direction over here. If this was like a greater than or equal to sign, if it had the little line underneath of it, we would fill in the circle, but it's an open circle right now. And now we've got another word problem. The unit cost for a piece of fabric is $4.99 per yard, including tax, and you have $30 to spend on material. How many whole feet underlined and bolded, could you buy? So we need to figure out how many whole feet of material we can buy with our $30 budget. But our $4.99 per yard is kind of in a different unit. So the first thing we want to do is figure out how much it would be to buy 1 foot of fabric instead of yards. So we're given the little conversion here that there's 3 feet per 1 yard. So to figure out how much a yard or a foot is going to cost, I'm just going to take that let me clear that off. I'm going to take this $4.99 and I'm going to divide it by 3. So we can say 1 foot of fabric is going to cost about $1.66. So my 30 is going to cost $1.66 per foot. I'm going to call how many feet I'm going to buy is going to be X. And this number cannot be greater than 30 because I don't have any more than $30, but it can be equal to 30, right? So this is going to have to be less than or equal to $30. I want to get X all by itself, which right now it has this 1.66 in front of it. So I'm going to divide by 1.66. X is going to be less than or equal to. I didn't have to flip my inequality sign this time because it wasn't a negative number. I'm going to do 30 divided by 1.66, and that is 18.07. I'm just going to kind of round there and say X is going to be less than or equal to 18 feet. And we want to write this in a number line. I take my 18, I put it in the middle. I do 1 number to the right. I do 1 number to the left. This time, X is less than or equal to 18, so I'm going to put a closed circle. And this arrow tells me the way I'm going to shade it. I'm going to shade it to the left where my numbers are getting smaller. So I can buy up to 18 yards, but I could also only buy 16 or 15 or 10 and still be within my budget of $30. In section 1.6, we learned about compound inequalities, which means we have 2 separate inequalities. This one you can see we have 2 inequality signs, and we want to solve this equation. We are going to split it up into 2 separate problems. So we're going to cover up one side, and we're going to solve the equation or inequality. 5 is less than k minus 2. That's going to be one of them. And the other one is going to be when we cover up the left-hand side, when I cover this one up. This is just going to be k minus 2 is less than 11. So this one is really just 2 problems disguised as one. We want to get k by itself, so I'm going to add 2 to both sides here. When I do that, I get k is greater than 7. I also like to write it with my variables on one side, so I'm going to write k is greater than 7 over here. And then on this one, I'm going to add 2 to both sides as well. And I get k is less than 13. So we can write our final answer here with k in the middle. And it's less than 13, but greater than 7. So maybe we'll put a cloud around this. This is our final answer. If we wanted to graph this, we need a place for 13 and we need a place for 7. They're going to be open circles because k is greater than and less than. There's no bar underneath of those lines. And when we are greater than one but less than the other, we shade in the middle between those two circles. And then we're going to kind of go backwards for our next problem, where we want to write the compound inequality of the graph by looking at the number line. So let's just pick a variable, and we're going to call it x because that's the one we mostly use. Over here, we need to express this as an inequality. Well, we can say x, and the place where we have the dot is the number that we're going to use, and 2. And we need to fill in what is the correct inequality sign. Well, x is definitely getting bigger. When we're shading to the left-hand side, my numbers are getting greater than 2. So I'm going to have a greater than sign. But then I also have to look at the nature of this circle. Was it an open or a closed circle? This one was closed, so I put a greater than or equal to sign. And then we do the same thing with the left-hand side. I'm going to start with my variable x again. I'm going to find my circle, and that's my number that I'm going to use. Here I'm shading to the left-hand side where my numbers are getting smaller. So I know x has got to be less than -4. And it's an open circle, so I don't write that line underneath. I'm just going to keep it my less than sign. Whenever I'm shading in, when I have two circles and I'm shading on the outside or the opposite direction, this is called an OR inequality. So it's either the orange or the blue. This one is called an AND inequality because these two things can be true at the same time. It's greater than 7, less than 13. So I'm shaded in the middle there. And last but not least, we're going to do absolute value. When we're solving for an absolute value, there's one thing that we need to remember, is that everything or any value that you plug into these bars, whether it's positive or negative, it's going to spit back a positive number. So I want to isolate this absolute value sign over here. It has a 7 out in front of it, so I'm going to divide both sides by 7. This is saying the absolute value of x equals 7. And once we get here, we can split this up into two different camps. We can say x is going to equal positive 7, because the absolute value of positive 7 is 7. That's correct. And then we can also say x is equal to -7, because if I plug -7 back in here, absolute values would tell me to make it positive, and that satisfies my equation as well. So my two solutions here are x equals positive and x equals -7. We can do something similar for this equation over here. Notice this time the number in our problem is inside the absolute value bars. If I don't have anything on the outside, then I'm going to go right away into splitting this up into my two problems. Y plus 4 is greater than 12. Or y plus 4 is less than 12. Oh, nope, that's not what I meant to write. I meant to write, don't switch the signs, y plus 4 is greater than -12. So once I split them up into the two camps, I want to go ahead and solve. I'm going to subtract 4 from both sides. Y is greater than 12 minus 4 is 8. So this is one of my answers here. And then this one, I'm going to subtract 4 from both sides. Y is greater than -16. And those are going to be my two answers there. And that's our last problem of this video. Hope this helped.